In this video, we're going to look at Cambridge International AS and A-Level Mathematics 9709, Probability and Statistics 1, paper 5.3 from May-June 2025. Question 1 says, for a set of 40 values of x, where k is a constant, given that the mean of these 40 values is 124, find the value of k. Now, in this case, we have sigma with brackets, and we need to find the mean. When working with brackets, we use the formula the estimated mean is equal to the value of the bracket. In this case, we have a constant of k, so let's say k, over n plus the constant of k. And we're going to use this equation to find the value of k. So let's start with the value of the bracket, 836, over n is the total set of values, which in this case is 40. So I can say 40 plus k is equal to the mean. And the question tells us the mean is 124. So to find k, all I need to do is move the fraction to the right. And I can say that k is equal to 124 minus 836 over 40. Take my calculator. 124 minus 836 over 40 is equal to, let's make it a decimal, 103,1. This is my value for k, 103,1. Part B says find the standard deviation of these 40 values of x. To find the standard deviation when working with brackets, we can say the standard deviation is equal to the value of the bracket squared. So in this case, sigma x minus k squared over n minus the value of the unsquared bracket, sigma x minus k over n, all squared. So let's put this into a bracket, squared, all under a square root. Please remember that this value here is not your mean. To find this value, we use the value of our unsquared bracket and we divide by n. So let's fill in our values. The squared bracket is 25,410,8 over n, which is 40, minus the value of the unsquared bracket, 836 over 40. Let's put this into a bracket squared, all under a square root. Now I can put this into my calculator. Let's create a root. I have 25,410,8 over 40 minus, let's open a bracket, 836 over 40 squared is equal to 14,087 and so on. Round off to 3 significant figures, and we see that the standard deviation is 14,1. Question 2 says, at a large college, all students who study science also study exactly one of art or drama or music. 20% of these students study art, 45% study drama, and 35% study music. 3 students are selected at random from the students who study science. Find the probability that at least one of these students studies drama. The word at least shows us that we are working with binomial distribution or geometric distribution. We're working with a total of 3 students. So we are working with binomial. So we're going to use the formula NCR multiplied by P with an exponent of R multiplied by Q with an exponent of N minus R. N is the total number of students. So in this case, N is 3. I'm going to make a note of this up here. N is 3. We're looking at students who study drama, and the question tells us that 45% study drama. So our value for P, 45% is a decimal, 0.45. Q is the complement, so Q has to be 0.55. We have N, P, and Q values, but we still need possible R values. The question says, find the probability that at least one of these students, at least one means one or more, 1, 2, or 3. And you can use 1, 2, and 3 as possible values of R. But in your exam, you do not have a lot of time. So in this case, I can say the probability that X is greater than or equal to 1 has to be equal to 1 minus the probability that X is 0. No students study drama. And I'm going to use 0 as my R value. So I can say that this is now equal to 1 minus NCR. N is 3, R is 0, multiplied by P, 0.45, with an exponent of 0, multiplied by 0.55, with an exponent of 3. When working with NCR, if your R value is 0, NCR is 1. So this is 1. Any value with an exponent of 0 is also 1. So here, I now have 1 minus 0.55 cubed. And I can take my calculator, and I can say 1 minus 0.55 cubed is equal to 0.833. Let's round this off to 3 decimal places, and I get 0.834. And now we can move on to part B. Part B says 10 students are selected at random from the students who study science. Find the probability that more than 7 study art or music. Now, we don't need to worry about students studying science. All of the students we are considering study science. The only thing we need to consider here are those that study art or those that study music. We need to find the probability that more than 7. So again, we are working with binomial distribution. So again, let's write my formula. NCR multiplied by P with an exponent of R multiplied by Q with an exponent of N minus R. In this case, we are considering a total of 10 students. So N is 10. We are looking at students who study art or music. Remember that when you have one probability or another, we add them together. 20% study art and 35% study music. 20 plus 35 gives us 55%. So the decimal, we can say P is equal to 0.55. Q is the complement, which is 0.45. We're looking at the probability of more than 7 students. So I can say the probability that X is greater than 7 out of a total of 10, which means we're looking at values where X is equal to 8, 9, or 10. These are the values we need to substitute into R. Let's start with 8. N is 10, so we can say 10 C8 multiplied by 0.55 with an exponent of 8 multiplied by 0.45 with an exponent of 2. Now we can look when x is 9. You can say 10c9 multiplied by 0.55 with an exponent of 9 multiplied by 0.45 with an exponent of 1. Let's add x values of 10. I'm going to write them down here. We have 10c10 multiplied by 0.55 with an exponent of 10 multiplied by 0.45 with an exponent of 0. When any value has an exponent of 0, it is 1. So when we multiply these values by 1, we don't need to consider it. So I'm going to scratch this out. And now we can put these values into our calculator. Let's start with NCR. I have 10C8 multiplied by 0.55 with an exponent of 8 multiplied by 0.45 squared plus 10C9 multiplied by 0.55 with an exponent of 9 multiplied by 0.45 with an exponent of 1. You don't need to write this down. Plus 10c10 multiplied by 0.55 with an exponent of 10 is equal to 0.09955. Round off to 3 significant figures and we get 0.0996. And this is our answer. A fair 6-sided dice with faces labeled 1, 2, 3, 4, 5, 6 is thrown repeatedly until a 3 is obtained. The number of throws taken is denoted by the random variable x. Part A says find the probability that x is equal to 8. If x is 8, that means that a 3 was obtained for the first time on the 8th throw. We have 6 numbers on our dice. There is 1 3. So we can see the probability of throwing 3 has to be 1/6, which means the probability of not throwing a 3 has to be 5/6. A 3 was obtained for the first time on the 8th throw. That means that the first 7 throws did not obtain a 3. So I can say the probability that x is equal to 8 is equal to not 3 for the first throw, or the second throw, or the third, all the way to the 7th throw. So we multiply 5/6 by itself 7 times. So let's put this in a bracket with an exponent of 7. On the 8th throw, we did get a 3. So we can multiply this. The probability of 3, 1/6. Now I can take my calculator. Let's open a bracket. 5/6 with an exponent of 7 multiplied by 1/6 is equal to 0.0465. Let's round off to 3 decimal places, 3 significant figures, and we get 0.465. And now we can move on to part B. Find the probability that x is smaller than 9. When we're working with smaller than, we are either working with binomial distribution or geometric. We are not given a total number of throws, so we know we are working with geometric distribution. When we're working with this, we can use the formula probability that x is smaller than or equal to r is equal to 1 minus q with an exponent of r. Make sure to learn this formula. It is not in your formula sheet. Please just be careful. We're using smaller than or equal to r. So if x is smaller than 9, then x has to be smaller than or equal to 8. So our r value is 8. from part A, we know the probability of rolling a 3 is 1 over 6, which means the probability of not rolling a 3, our Q value, has to be 5 over 6. So now I can say the probability that x is smaller than or equal to 8 is equal to 1 minus 5 over 6 with an exponent of 8. Take my calculator. 1 minus the bracket of 5 over 6, an exponent of 8 is equal to 0,76743 and so on. Round off to 3 significant figures and I get an answer of 0,767. Part C says find the probability that a 3 is obtained for the second time before the 6th row. We know that the probability is 1 over 6 and the probability of not is 5 over 6. Remember that statistics is realistic, so we need to look at this as a real life situation. We are looking at the probability that a 3 is obtained for the second time before the 6th throw. If a 3 is obtained twice, it cannot be on the first throw. So now we have to look at 2 throws, 3 throws, 4 throws, and 5 throws. But remember that when the second 3 is obtained, the game ends. Keep that in mind while working through this question. If we get 2 3s in 2 turns, that means we get 1 3 followed by another 3. If we use 3 turns, the second 3 has to be obtained on the 3rd turn. In the first 2 turns, we're going to get 1 3 and one value that's not 3. I'm going to say 3 and not 3. I'm going to put this into a bracket. If the second 3 is obtained on the 4th turn, we're going to have our second 3 on the 4th turn, which means from the first 3 turns, we're going to get 1 3 and 2 values that are not 3. Let's put this into a bracket. If 3 is obtained on the 5th turn, in the first 4 turns, we're going to get 1 3 and 3 values that are not 3. Let's start with our probabilities. In 2 throws, I get 3 and 3. So I get 1 over 6 multiplied by itself. So I'm going to say 1 over 6 squared. For 3 throws, I'm going to get 3 and 3. 1 over 6 squared. And no 3, so multiply by 5 over 6. In 4 throws, I'm going to get a 3 and another 3. Again, 1 over 6 squared. And no 3 and no 3. So we multiply by 5 over 6 squared. In 5 throws, I get 2 3s, 1 over 6 squared, and no 3 and no 3 and no 3. So we multiply by 5 over 6 cubed. In our second throw, we're in 2 throws. We can only get 3 and 3. We can leave this as it is. But in 3 throws, we can get 3 first and then a value that's not 3, or we can get the value that's not 3 first and 3 second. There are 2 ways that we could see this. So we need to multiply this by 2. Out of 4 throws, the second 3 is 4th, but in the first 3 throws, the 3 could be first, second, or third. So we need to multiply these values by 3. For 5 throws, the second 3 is fifth. That's not moving. But in the first 4 throws, 3 could be first, or second, or third, or fourth. So we need to multiply this by 4. These are the different options that we have to work with. But the question is asking us to find the probability that a 3 is obtained for the second time before the 6th throw. It could be obtained on the second throw, or the third throw, or the fourth throw, or the fifth throw. That means that now we need to add these values together. Because of all the brackets, I know that 1 over 6 squared is 1 over 36. So I'm going to say 1 over 36 plus 1 over 36 multiplied by the bracket of 5 over 6 multiplied by 2 plus 1 over 36 multiplied by 5 over 6. Close the bracket squared, multiplied by 3 plus 1 over 36 multiplied by the bracket of 5 over 6. Close the bracket cubed, multiplied by 4 is equal to, let's make it a decimal, 0,1962 and so on. Let's round off to 3 significant figures and I get an answer of 0,196. Question 4 says 84 people attempt a particular puzzle. The times taken in minutes to complete the puzzle are recorded. These times are represented in the cumulative frequency graph below. Part A. Use the graph to estimate how many people took between 4 and 7.5 minutes to complete the puzzle. We can use 4 and 7.5 minutes to find the number of people. So let's start with 4 minutes. We can draw a vertical line up from 4 to our graph and then horizontal to the y-axis. We can see that this touches the y-axis at 26. Now let's look at a time of 7.5 minutes. Draw a line up to the graph, then horizontal to the y-axis, and this touches the axis at 69. So to find the number of people who took between 4 and 75 minutes, all we need to do now, you can say 69 people minus 26 gives us a total of 43 people. That is our answer. Now we can move on to part B. On the grid below, draw a box and whisker plot to summarize the information in the cumulative frequency graph. To draw a box and whisker plot, we need 5 values: minimum, maximum, lower quartile, Q1, the median, Q2, and the upper quartile, Q3. And we can use the cumulative frequency graph to help us with these values. The values we need are the times taken. We can see the lowest value is 2 and the highest is 12. So let's make a note of this. I can say my maximum value is 12 and my minimum value is 2. Now I need my 3 quartiles. The values of the quartiles are going to be times, but to find these, we use the cumulative frequency. The total frequency is 84. So I can say 84 divided by 4 gives me 21. And I can use this to find the lower quartile Q1. So from the y-axis, I'm going to draw a line from 21 to the curve and then down to the x-axis and this touches at about 3,8. So I'm going to make a note of this over here. Now I can go back to my graph. 21 plus 21 gives me 42. The cumulative frequency of 42 will give me the median Q2. So let's draw a horizontal line to the curve and a straight line down to the x-axis. This touches the axis at about 4,8. So let's make a note of this. And finally, I can find Q3. 42 plus 21 gives me 63. So let's draw a line from 63 to the curve and down to the axis. And I get a time of 6,6. And now I can make a note of this as well. Now I have all 5 values, and I can use this to plot my graph. Before we do this, we need to consider intervals along the x-axis. I have 2, 4, 6, 8, 10, 12 blocks to work with. I have a minimum value of 2 and a maximum value of 12. So let's number our x-axes from 0 to 12. These are the times taken. So we can label the x-axis time in minutes. Now we can plot the points for all of these values. Always do this about halfway up of your graph. So the minimum value is 2. Let's plot this point. The maximum value is 12. We can plot that point. Q1 is 3,8. That will sit about there. Q2, 4,8 will sit around here. And Q3, 6,6 will sit there. And now I can draw my graph. So let's start by drawing the box. Now I can draw in my tail on the left and my tail on the right. I can put a small line over here and over here. And now we've completed the box and whisker plot. Question 5 tells us that bag A contains 6 red marbles, 5 blue marbles, and 1 green marble. Bag B contains 5 red marbles and 3 blue marbles. A marble is chosen at random from bag A and placed in bag B. A marble is now chosen at random from bag B. Part A says draw a tree diagram to represent this information, giving the probability on each branch. We're working with 2 bags, so we need to draw branches for bag A and for bag B. Bag A contains red marbles, blue marbles, and green marbles, so we need 3 branches for bag A. Let's label our first branch R for red, B for blue, and G for green. Bag A contains 6 red, 5 blue, and 1 green marble. It gives us a total of 12 marbles. So there are 6 red. The probability of red is 6 over 12. 5 blue, the probability of a blue marble, 5 over 12. So 1 green marble, the probability of green has to be 1 over 12. Now we can look at bag B. Bag B contains 5 red and 3 blue marbles. It gives us a total of 8 marbles. But the question tells us that a marble is chosen from bag A and placed in bag B. So regardless of the color of the marble chosen, we are adding an additional marble to bag B, which means we will have a total of 9 marbles. So let's look at if the marble from bag A is red. If we add a red marble to bag B, we will still only have red marbles and blue marbles. So from R, we can draw 2 branches. Let's name the top one R for red and the second one B for blue. Originally, we had 5 red marbles. We're adding another marble, which means now we have 6 red marbles out of a total of 9. We still only have 3 blue marbles. The probability of blue has to be 3 over 9. Now let's look at what happens if the marble from bag A is blue. If we add a blue marble to bag B, we will still only have red marbles and blue marbles in the bag. So again, we can draw another 2 branches. Let's label the top branch R for red and B for blue. We are adding a blue marble, which means we still only have 5 red marbles. So the probability of red has to be 5/9. We are adding 1 blue marble to the original 3. So the probability of a blue marble has to be 4/9. Finally, let's look at what happens if the green marble from bag A is chosen. If we put this marble into bag B, we now have red marbles, blue marbles, and a green marble. So we need 3 branches from G to accommodate for the green marble. Let's label this R for red, B for blue, and G for green. We are adding a green marble, which means the number of red and blue marbles in the bag doesn't change. So the probability of red is 5/9. There are still 3 blue marbles. The probability is 3/9. We now have 1 green marble. So the probability is 1/9. And we have now completed our tree diagram. Part B says find the probability that both marbles chosen are the same color. If both marbles are the same color, we could have a red marble first and a red marble second, or we could have a blue marble first and a blue marble second, or we could have a green marble first and a green marble second. We can use our tree diagram from part A to find the respective probabilities. Let's start with our red marbles. If we have a red marble in bag A, 6/12, and a red marble in bag B, 6/9, we're working with one probability and another. So we can multiply these together, 6/12 and 6/9. Or we could have 2 blue marbles. So now we need to add a blue marble from bag A, 5/12, a blue marble from bag B, 4/9, a blue marble and a blue marble. So we need to multiply these as well, 5/9 and 5/12 and 4/9. Or we could have 2 green marbles. So again, we need to add a green marble from bag A, 1/12, and a green marble from bag B, 1/9. 1/12, green marble from bag A, and 1/9, a green marble from bag B. And you can put this straight into your calculator. So I can say 6/12 multiplied by 6/9 plus 5/12 multiplied by 4/9 plus 1/12 multiplied by 1/9 is equal to 19/36. So I can leave my answer as 19/36. Part C says find the probability that the marble chosen from bag A is blue, given that the marble chosen from bag B is blue. The word given tells us that we are working with conditional probability, and we can use the formula, the probability of B given A is equal to probability of B and A over the probability of A. In this case, we have probability that the marble from bag A is blue. I'm going to say blue marble from bag A, given the marble from bag B is blue. Bag B has a blue marble is equal to the probability of a blue marble from bag A and a blue marble from bag B all over the probability of a blue marble from bag B. Let's start with the probability of a blue marble from bag A and a blue marble from bag B. If that happens, we get a blue marble first, I'm going to write that up here, and a blue marble second. Let's look at our tree diagram. A blue marble first, 5/12, and a blue marble second, 4/9. We have a blue marble and a blue marble, so we multiply these together. 5/12 multiplied by 4/9. I'm going to multiply these together quickly, and I get 20/108. And I can leave my fraction as it is for now. Now we need to look at the probability of a blue marble from bag B. But if the marble from bag B is blue, the marble from bag A can be any color. So we could have a red marble from bag A, followed by a blue marble from bag B, a blue marble from bag A, and a blue marble from bag B. Or we could have a green marble from bag A and a blue marble from bag B. Again, let's look at our tree diagram. Let's start with a red marble from bag A. A red marble from bag A, 6/12, and a blue marble from bag B, 3/9. We have a red marble and a blue marble, so we need to multiply these together. 6/12 and 3/9. Or 2 blue marbles, so we add. We already know that the probability of 2 blue marbles is 20/108. So I can fill this in over here, 20/108. Or a green marble and a blue marble. Let's look at our diagram. Probability of a green marble first, 1/12, and a blue marble second, 3/9. Now I can say 1/12 multiplied by 3/9. Now I can put this into my calculator. 6/12 multiplied by 3/9 plus 20/108 plus 1/12 multiplied by 3/9 is equal to 41/108. I'll make a note of this over here, 41/108. Now I can fill my values into the formula. I'm going to make some space. And we can say the probability of a blue marble from bag A, given the marble from bag B is blue, is equal to a blue marble from bag A and bag B, 20/108, over the probability that the marble from bag B is blue, 41/108. And you can put this into your calculator. We can see the 108 will cancel out, and we're left with a probability of 20/41. Question 6 tells us that a company sells bags of pasta. The masses of large bags of pasta are normally distributed with mean 2,5 kilograms and standard deviation 0,12 kilograms. Part A says find the probability that the mass of pasta in a randomly chosen large bag is less than 2,65 kilograms. The masses are normally distributed, so we're going to use the formula Z is equal to X minus mu over sigma. the mean, mu, is 2,5 kilograms, and the standard deviation is 0,12. The question tells us that we are looking for bags less than 2,65 kilograms. This is our x value. I can say that z is equal to x 2,65 minus mu 2,5 over standard deviation 0,12. Take my calculator and I can say 2,65 minus 2,5 divided by 0,12 is equal to 1,25. So z is equal to 1,25. Now to find the probability, let's look at our distribution table. Z is 1,25. So we have 1,2 across to 5, and we get 0,8944. So the probability is equal to 0,8944. And now we can move on to part B. A restaurant manager buys 160 of these large bags of pasta. Find the number of bags for which you would expect the mass of pasta to be more than 1,65 standard deviations above the mean. We need to find the number of bags. And we know we have a total of 160. But to find the number of bags, we first need the probability. The question tells us that the mass of pasta will be more than 1,65 standard deviations. Your z-score is the number of standard deviations. So over here, I can say that z is equal to 1,65. We are working with data that is normally distributed. So I'm going to draw a quick bell curve. There's my mean, and we want 1,65 standard deviations, which will sit, let's say, somewhere over here, 1,65. We are looking for values greater. So we're looking for this section over here. Let's start by finding the probability that z is 1,65. I can take my normal distribution table. I have 1,6, 5, and I get 0,9505. Over here, I can say probability of z is equal to 0,9505. But remember that when working with normal distribution, the distribution table gives us the area to the left, the probability that something is smaller. So in this case, to find the probability that it is larger, we need to subtract this value from 1. So I can say that this is now equal to 1 minus 0,9505. Take my calculator. 1 minus 0,9505 is equal to 0,0495. 0,0495. This is my probability. And to find the number of bags, all I need to do now is multiply this by 160. So take my calculator, let's multiply by 160 is equal to 7,92. We're working with full bags, so let's round up to the nearest whole number. We get an answer of 8 bags. Part C says the masses of small bags of pasta sold by the company are normally distributed with mean mu kilograms and standard deviation sigma kilograms. Tests show that 77% of these bags have masses greater than 1,26 kilograms and 44% have masses less than 1,35 kilograms. Find in either order the value of mu and the value of sigma. We're working with normal distribution, so we're going to use the formula z is equal to x minus mu over standard deviation sigma. we need to find the value of mu and the value of sigma. We have two unknown variables, which means we need to use simultaneous equations. And if we can find values for z and values for x, we can create two equations that we can use to solve. The question tells us that 77% of these bags have masses greater than 1,26 kilograms. So the probability that x is greater than 1,26 is equal to 77% as a decimal, 0,77. But remember that when working with normal distribution, we look at values smaller. So the probability that x is smaller than 1,26 has to be 1 minus 0,77, which gives us 0,33. Now we cannot find 0,33 in our normal distribution table, but a value smaller than 0,5 tells us that our z value will be negative. So now I can say probability of a negative z value is going to be 1 minus 0,33, which we know is 0,77. Now I can find 0,77 in my normal distribution table. The closest we have are these two over here. And remember, we always use the smaller value, 0,7673. This shows us that we have 0,73. So z will be negative 0,73. But we need to add another 27 onto here to get 0,77. So in our final column, let's find 27 over there, which means we add 9 to our z score, and z becomes negative 0,739. Let's make a note of this over here. Z is equal to negative 0,739. Now we have a value for z and a value for x. Let's see what else we know. 44% have masses less than 1,35. So the probability that x is smaller than 1,35 is equal to 44% as a decimal, 0,44. Again, the probability is smaller than 0,5. So again, our z value will be negative. So I can say the probability of negative z is going to be equal to 1 minus 0,44, which is equal to 0,56. And now I need to find 0,56 in my normal distribution table. Here I have 0,5s, 0,5, 0,5596. That is the closest value, still smaller than 0,56. From this, I can see that I'll have a z score of 0,1. 5. Z is negative. So I have negative 0,15. But I need to add 4 to get 0,56. And I can see that if I add 4, I need to add 1 to my z score. So now I have a z score equal to negative 0,151. Now I want to make some space, and I can make a note of my x score and my z score on this side, negative 0,739, and on this side as well, x is 1,35 and z is negative 0,151. With these values, I can put them into the formula. So I can say that Z, negative 0,739 is equal to X 1,26 minus mu over sigma. We need to solve for sigma and mu. So let's multiply both sides by sigma. And I get negative 0,739 multiplied by sigma is equal to 1,26 minus mu. To solve for mu, it needs to be positive. So let's move it to the left. And I get that mu is equal to 1,26 plus 0,739 sigma. This is our first equation. Now let's do the same for the other side. My z-score is negative 0,151 is equal to x 1,35 minus mu over sigma. Multiply both sides by sigma. I get negative 0,151 sigma is equal to 1,35 minus mu. Let's make mu positive. I get mu is equal to 1,35 plus 0,151 sigma. Now I have two equations, and remember that mu over here is equal to mu on this side, which means our equations are equal as well, and we can use them to find the value of sigma. I'm going to make some space. And now I can say that equation 1,26 plus 0,739 sigma is equal to equation 2, 1,35 plus 0,151 sigma. We're solving for sigma, so let's move our sigma terms to the left. I have 0,739 sigma minus 0,151 sigma is equal to 1,35 minus 1,26. And now I can add like terms. So I can take my calculator and I can say 0,739 minus 0,151 is equal to 0,588. So on the left, I have 0,588 sigma is equal to 1,35 minus 1,26 is equal to 0,09. 0,09. To find the value of sigma, all I need to do is divide both sides by 0,588. So I can say 0,09 divided by 0,588 is equal to 0,153 and so on. Leave your answer to 3 significant figures. And I see that sigma is equal to 0,153. Now that I have sigma, I can find mu, and I can substitute this value of sigma into either equation. I'm going to use the one on the right. So I can say mu is equal to 1,35 plus 0,151 multiplied by sigma 0,153. Take my calculator. 1,35 plus 0,151 multiplied by 0,153 is equal to 1,373. Round off to 3 significant figures, and I see that mu is equal to 1,37. A set of friends consists of 7 men and 4 women. 3 of the men are brothers, Ali, Ben, and Charlie. Part A says find the number of different arrangements of the 7 men in a line in which Ali and Ben do not stand next to each other. The easiest way to do this is to find the number of arrangements without restrictions and then subtract the number of arrangements where Ali and Ben do stand next to each other. This line consists of 7 men. So for arrangements without restriction, we simply say 7 factorial. I'm going to leave it like this for now. Now let's find the number of arrangements where Ali and Ben do stand next to each other. So I'm going to put Ali and Ben together in a bracket. We have 2 men out of a total of 7. So we have another 5 over here. We count the bracket as 1. So now we have 6. So I can say 6 factorial. We have Ali and Ben inside the bracket. So we multiply by 2 factorial. To find the number of arrangements where Ali and Ben are not together, I can now say 7 factorial. Total arrangements minus 6 factorial multiplied by 2 factorial. Take my calculator. 7 factorial minus 6 factorial multiplied by 2 factorial is equal to 3,600. This is the number of arrangements where Ali and Ben do not stand together. And now we can move on to part B. Find the number of arrangements of the 7 men and 4 women in a line in which all the men stand together and all the women stand together. Let's put 7 men together over here. Let's put this into a bracket. And 4 women together. And this in a bracket as well. We have 2 brackets. So we have 2 factorial. There are 7 men in our first bracket. So we need to consider the arrangements for these 7 men. So we can multiply by 7 factorial. We have 4 women in the second bracket. So we multiply by 4 factorial. Now I can take my calculator. 2 factorial multiplied by 4 factorial multiplied by 7 factorial is equal to 241,920. 241,920. This is the number of arrangements. And now we can move on to part C. In how many ways can the 7 men and 4 women be divided into a group of 6, a group of 3, and a group of 2 if there are no restrictions? Now be careful with this word, no restrictions. There are no restrictions in terms of the brothers or men together, women together, and so forth. However, there are restrictions on the number of people in each group. Group 1 has to have 6 people. Group 2 has 3 people. And Group 3 has 2 people. We have 7 men and 4 women, which gives us a total of 11 people. For Group 1, we have a restriction of 6. So I can say 11C6. After filling Group 1, I've now used 6 people, so I'm left with 5. Of those 5, I need 3 to fill my second group. I say 5C3. I have 2 left, and they will fill my third group, 2C2. Now, I have 6 people in Group 1, and 3 people in Group 2, and 2 people in Group 3. When working with NCR, keep in mind that when N and R are the same value, 2 and 2, NCR is equal to 1. So to find the number of combinations, all I need to do now is multiply 11C6 by 5C3. So I can take my calculator, say 11C6 multiplied by 5C3 is equal to 4,620. This is the total number of combinations. And now we can move on to part D. The 7 men and 4 women are divided at random into groups of 6, 3, and 2. Find the probability that Ali, Ben, and Charlie are all in the same group. Let's start by looking at the different ways that all three brothers could be in the same group. We have a group of 6 people, a group of 3 people, and a group of 2 people. All three brothers could be in the 6-person group. So let's say Ali, Ben, and Charlie, and then another 3 people in group 3, and 2 people in group 2. The brothers could also be in the 3-person group. So let's put Ali, Ben, and Charlie over here. We have 6 people in the first group and 2 people in the third group. The third group can only hold 2 people, so we cannot fit the 3 brothers into this group. So these are the only 2 options that we can consider. We have 7 men and 4 women, which gives us a total of 11 people. But we've already placed the 3 brothers, so we now need to place the other 8 people. Let's say that this is option 1 and this is option 2. Let's start with option 1. I have to place 8 people in 3 spots. So I say 8C3. I have 5 left. I need to place 3 in group 2. So I can say 5C3. I have 2 left over, and I can place them in the third group, 2C2. For option 2, I have 8 people, and I need to place 6. So I can say 8C6. I have the 3 brothers in group 3, we can leave that, and then 2 people in group 3, 2C2. But remember that 2C2 is equal to 1. So we can cancel that and cancel that. Now I need to consider option 1 or option 2. So I need to add these together. So I can take my calculator and I can say for option 1, 8C3 multiplied by 5C3 plus option 2 of 8C6 is equal to 588. This is the total number of combinations, but this question is not asking us to find the number of combinations. It is asking us to find the probability that the 3 brothers are all in the same group. And to find this probability, we divide our number of combinations by the total number of combinations, which we found in part C to be 4,620. Let's divide by 4,620, and I get 7/55. This is the probability that all 3 brothers are in the same group.